This morning we're going to talk about vowels. So all of the human speech sounds, the kinds of sounds that we use in spoken language, are displayed on this chart. Speech sounds in general, which we can refer to as phones. This is like the Greek word telephone, meaning sounds at a distance. Tele is at a distance. So these phones can be divided into segmental phones, segments like sort of like segments of words, which are the ones we normally think about, vowels and consonants. And vowels themselves can be divided into two classes. Vowels can be either single vowels or they can occur in groups, diphthongs. Di is Greek for two, phthong is Greek for vowel, and that's where that comes from. Suprasegmentals are things that we can do to sound that go over top of those segmentals, hence the word supra, kind of on top of. So we can add stress to these vowels and consonants. We can add pitch, and pitch changes that go over the length of a single sound are called tone, and pitch changes that go over the length of a whole group of sounds would be intonation, like that would be an intonation pattern. In this presentation, we're going to focus just on vowels and especially just on single vowels. So this sort of blurry chart, what's going on here? On the x-axis, we have time, measured in seconds, and on the y-axis, we have frequency, measured in hertz. If you don't remember what frequency is, sound waves go in the air sort of like waves in the ocean, and frequency is a measurement of how closely spaced these sound waves are. So you could think of it as being how many waves would hit something per second, hit the shore per second. In a way, that would be a high frequency sound if many of these are hitting per second. It would be a low frequency sound if few of these are hitting per second. Frequency could also be measured as something called wavelength. So how long is each wave, like how wide or deep is each one. So if you have a higher frequency sound, they're going to be more tightly spaced together, so their wavelength is going to be smaller. So a small wavelength means a high frequency. And a long wavelength, that these things are very wide because they're further apart, would be a low frequency sound. And low frequency sounds are what are heard by our ears as being low pitched. A high frequency sound would be high pitched. If you've ever played a musical instrument, you know that a sound has several different harmonics. One of the things that makes computer sounds so artificial sounding is that they only have a single harmonic, like a pure tone, like a computer beep in the old days. But most sounds would have layers of resonance. Would all be going at the same time. This is what makes a flute sound different from a trombone. It's what makes your best friend sound different from your mom. Each resonating body would produce different harmonics, different frequencies. And by changing the shape of a body that's resonating, you can actually change the pattern of these frequencies. And this is what happens with human vowels. So in a chart like this letter that looks like the letter I is actually a symbol for the sound E. So if this would be me being silent and then saying E, and then being silent again, saying E, silent, E, silent, A, silent, Ah, silent, O, silent, Oo. And this readout is actually at all of the different frequencies, from low frequencies to high frequencies, how much energy is being produced. If it's dark, that means there's a lot of energy at that frequency. If it's light, that means there's not much energy at that frequency. And that's why the silence looks completely white, because there's no sound really coming through at all. What we notice is that there's two bands of intense energy, a low one, and then the next one up. And these are what we call F1, formant 1, and F2, formant 2. And in these different vowels, these bands are differently spaced. In an E vowel, you get a lot of energy at this low frequency, and then you also get a lot of energy at this high frequency, and then there's multiple formants above that. A, they're a little closer together. I've changed the shape of my mouth, so the resonance looks a little bit different, the pattern. These two, F1 and F2, are closer together. In E, they're even closer together, and A, they're very close together. And this is what my brain uses to hear the difference between vowels. The hairs on my ear pick up what how much energy is being produced at the different frequencies, at the different wavelengths, kind of like a car antenna would do with a radio station. And then it turns that into what sounds like a noise in our head. So we can see that different vowels have these different F1 and F2 values. In a more simplified version of the chart, it would look like this. I, E, A, O, U. You can see that the first formant kind of rises a little bit toward the A, and then it goes back down toward the U. And then the second formant is way high for an E, and it's dropping all the way to an U. The onset with a B, there'll be a slight rise into that formant. With a D, there'll be a sharp fall into that formant on the F2. And then with a G, there'll be a slight fall on the F2 and a slight rise on the F1. So the consonant that happens before the vowel will actually change the nature of the acoustics of the vowel itself, which is part of how we hear a consonant. We're really listening for the consonant's effect on the following vowel. So again, if we have this kind of a chart with I, U, A, this one is a little clearer. You can see the first formant, the second formant, the first formant, the second, the first, and the second. And the computer is able to extract that from a signal. We can actually plot the F1, F2 values. So F1 here looks like it's about, I don't know, maybe 350. F2 looks like it's about 2500 hertz. That's the measurement for frequency. So if I have something like 250 and 2500, that's right in E territory. So any vowel that's values are going to be like this will sort of be heard by my English-speaking brain as if it was the vowel E. Any vowel that's formant values are going to be in this territory will be heard by my English-speaking brain as an I, or E, A, U, U. So all of these different things, if I spoke a different language, I might have a different set of things that I'm listening for. That would be the blue ones or the red ones. But so you can see that in some languages, what they would hear as an O gets heard by my English-speaking brain as if it were an U. So these are these formant values. Now if we take this chart, which we have here, we can actually rotate it 90 degrees. Why would we want to do that? Well, you'll see. So if we have it like this, so now E is over in this corner and U is there, and then we rotate it 180 degrees so that we have E sort of at the front and U at the back, and then we have kind of A down at the bottom here. What this sort of matches up to, it sort of neatly and kind of coincidentally perfectly creates this sort of trapezoid shape, which is this trapezoid shape in the middle of our mouth. It turns out that an E vowel would be sort of pronounced up here with our tongue, an U would be back there, an A would be down here. So this is kind of this trapezoid shape we'll see a lot with vowels, where it fits in the vowel chart. So yeah, these are the lips. So my tongue would be going up here, my tongue would be going back there, here in the middle, and down to the bottom. And so we can actually see, if you were to say ah, that would mean ah would be right down here at the bottom. My tongue is getting way down and getting out of the way. That's why the doctor tells you to say ah, because then your tongue is way pressed at the bottom of your mouth, out of the way, so the doctor can look back and see what's going on in your throat. This one is a little bit more accurate about what the actual shape in the mouth is like. It's a little bit more like a flat line on this side, a diagonal line on this side, and it's much smaller in the mouth. So this curve here would represent where my tongue is for the vowel E. This is where my tongue would be for the vowel U. And this in the middle is sort of where my tongue would be for the vowel and then I'd have ah down here at the bottom. So my tongue would be even getting further out of the way so the doctor could see the back of my throat. Here we can divide it like this. If we divide that shape into 9 quadrants, this creates what we often call the vowel space, and we use this little graph of 9 quadrants to show where in the mouth vowels would be. So E could be up here, and it's actually at the top and at the front of this quadrant. So we call this a high front vowel. Our tongue is high in the mouth, it's further forward in the mouth, and it's at the very top and the very front of this vowel space. An oo is going to be back here. We call this a high back vowel. Our tongue is at the top, it's high, but it's pushed all the way back toward the back of our mouth. You can see that steep drop off. So we call this a high back vowel. So E is a high front vowel, oo is a high back vowel.